So once again, I welcome you all for AICT Training and Learning Academy sponsor 6 days online faculty development program on AI assisted integration of renewable energy sources into EV charging networks at Solamalai College of Engineering, Madurai. So today is the third day of our FTP. So today also we have two sessions. In the first session, our resource person is Dr. Sheikh Mohammed Sultan sir, Deputy Director, Center for Transport Research, University Technology, Pune, Darussalam. So all are well known about our resource person already presented the session, presented topic in session 1 now. Directly we go to this session. So welcome you, sir. Sir, Dr. Sheikh Mohammed Sultan, sir.
Yeah, thank you.
Can you
Thank
hear
you
me,
very
sir?
much. Yeah,
Uh,
I hope you can hear me, right? Yeah, okay. You hear me, Radhalakshmi?
yes, sir.
Okay. Okay, fine. Thank
Okay, sir.
you.
No problem. You can share your PPT, sir. No problem.
Okay, okay.
Mm. Sir, one more thing, sir. So, all participants are requested to please keep interact with our resource person. All are eminent person. We are invited eminent person from outside of Tamil Nadu and also India. So, please keep interact with our resource person. It's a humble request. Okay, sir, no problem. You can start, sir.
Yeah, okay, okay. Wait, yeah. Is my screen audible to everyone?
Yes, sir. Yes, sir. You.
Okay.
Yes, sir. Yes, sir.
Thank you. So, once again, good evening to everyone attending this session today. And I would like to thank once again Solamalai College of Engineering for giving me opportunity to talk on another topic, which is a application for a application in EV charging. I just would like to know, like, what I just would like to add a few things before I start my session on top of what Dr. Radhalakshmi highlighted here. Uh, the institutions are putting a lot of effort to conduct such kind of faculty development programs or skill development programs on particular areas, and they work with people nationally and internationally to find them suitable expertise from their field, and most importantly, when we, like, we are just presenting 1 hour session, but you should understand how much effort we need to put on in order to prepare this 1 hour session, and how many communications have been happening, how much manpower we are spending in order to make it happen. It is just a session of 1 hour, which I am going to present now, but for how many weeks we have been discussing, how many communications, how many emails, how many phone calls have happened, and how much time we put, our effort, we are putting our effort in order to prepare the PPTs to deliver the best of what we can do. Ultimately, what do we expect? Being a resource person is an interaction and response from the audience. Uh, I'm, like, it's a sad part, but I must say that in most of the cases, by the time when we present the thank you slide of the session, the first message we see in the chat box is the request for the attendance link and the feedback. it is so embarrassing, for a person who is delivering a session for 1 hour, 1 hour, 15 minutes, after preparing this by spending hours of time, at the end, that is a value which is being delivered to the speakers. That is kind of embarrassing, and it is making us to feel kind of disappointed. I just shared my it is all my personal thought, and I have a feeling that each and every speaker who is delivering the session would have the same thought. With these things, with this note, I just like, you are attending sessions, the sessions are being prepared in such a way. If you are really attending the session to gain knowledge, please interact with the resource persons. I don't mean me, but I request you all to interact as much as you can with every resource person who is coming to deliver the sessions. Good evening to all and all again. I just would like to move on to AI applications in EV charging is a topic which I am going to talk about today. I will just try to finish it as early as possible within the time frame. We'll start with the energy transition. We have been discussing on the other day about the electric vehicles, different types of charging stations, and also the need for renewable energy based charging solutions. When it comes for energy transition refers to the transformation from the fossil fuel based energy system into renewable energy based energy system, which cover all type of renewable energies, and also it cover the battery energy storage systems. A quick overview on the global market of EVs based on the data available on raw motions. If you have a look at this data, how it is, from 2012 until 2024, it is giving a data of nearly 22 years. As we can say that the electric vehicle fleet is expected to grow 12-fold by 2035, and according the policies which are currently available, which means that the light duty vehicles are expected to have 40% hike by 2030, and it will reach up to 55% of the total contribution of the vehicles in the market by 2035. And electric buses are also expected to contribute 30% by 2035. And one another thing which we need to look at it, if you look at the graph and if you look at the fine. If you look at the colors which are representing the country, as you can see that from 2015, the electric vehicle market is rapidly rising in China, and the second most popular market is in Europe. Then it is going to United States, and the rest of the world is contributing only two. If you look at these numbers from here, it is above 15, it is between 15 to 16. It is only 2%, I can say, among the whole. It is not 2%, but this is given in terms of the numbers. But when you look at this one, more than 50% is contributed by China alone. And this is the EV sales projection. This is especially for China, and this one is for India based on the current scenario and what it is to be expected in another few years, which is expected to be in 2035. As we can see here, China is expecting two-wheelers are expected to be more than 85%. When it is coming to India, it will be around 70%, and light duty vehicles are expected to be contributed 75, more than 75%. On the other hand, it will be around 65% in India. Electric buses will also dominate the market in China by 2035 with 70%. Here, when it is coming for, it is another again 65% nearly. This is the global EV market statistics based on row motion, where we can see that the global market has 17.1 million vehicle as of 2024, which is 25% increase when compared to 2023. And what we are seeing here is that there were, just to have a look at the numbers comparing to 2023, China had 40% increase in its sale with 11 million over the 17 million, which is nearly 60% of the global market. European Union and UK contributed together 3 million, USA and Canada contributed 1.8 million, and rest of the world is contributed 1.3 million. Though the rest of the world has 27 percentage increase, still the number is low, which means that when you compare to the 17 million, 10 percentage is nearly 1.7 million, which means that the rest of the world is contributing less than 10 percentage of the global electric vehicle market. These are the key takeaways from the global market in 2024, where, as I mentioned before, China had China market had grown up 2% on month-to-month basis, and it had a sales of 36 percentage year on basis by 2024, and the overall growth is 40 percentage in 2024. Therefore, when we look at this one, another important factor is that I'm sure that BOED is hitting the market of India also. But when we look at the global scenario, it is not only in China, but BOED is capturing market everywhere across the globe. Even last year, there was a scenario that Volkswagen was shutting down its plant in Europe because of the poor market. One key reason is that BOED was capturing the market. Norway is expected to be continuous highest penetration with the highest penetration rate of 90% passengers cars by the end of 2024. This is the market scenario in India. The total EV sales in India has reached 14 lakh 8,245, which is only 5.59 percentage increase. But it is still having a higher penetration than the year 2023, which was only 4.44 percentage. Maruti has planned to set up 100 fast chargers across the cities in India. Tata Motors and Hyundai are expecting to set up 500 to 600 public chargers. You may think that why I am talking about all these statistics when we are about to talk about AI application in EV charging. We will slowly get into it. If you are really working on electric vehicle, or if you are keen on electric vehicle research, or you are teaching a subject on electric vehicle, you must have been aware of the target of Indian government having 30 percentage of private cars, 70 percentage of commercial vehicles, and 80 percentage of two-wheeler and three-wheeler in the in the Indian market share by 2030. And as it is going by this trend, on business as usual scenario, 40 percentage year on year growth is about 106 million EVs by 2030. This is the expectation. 2030 means in another 6 years, it is expected that Indian roads will have 106 million EVs on the roads. These are some of the prominent models of electric vehicles and their charge rating. We have already seen some of them. I will just skip this slide. These are some of the vehicles available in Indian market. Have a look at this one. We are more, focusing on this one. Tata Nexon has 30.2 kilowatt hour, MG 44.5 kilowatt hour, Hyundai 39.2, Mahindra E2 11 kilowatt hour, Mahindra E Verito 19 kilowatt hour, Mahindra XUV 300 42 kilowatt hour. It varies by model, but still it is okay. And Bajaj Chetak is a scooter with 3 kilowatt hour. EV India Xenia is 3 kilowatt hour, which is another two-wheeler. I think that I have made some changes in these slides, but it is okay. So you can just, if you know the answer for this question, you can just post your answer here. Let me once again, let me just, you don't have to really go into Menti. I will just wait for a second.
Sir?
Once again, please.
No problem, no problem, no problem.
My screen is visible now, right?
Yes, sir, yes, sir.
Okay, great. So, just I have posted a question here. What is the average, like, do you have some idea what is the average electricity consumption in your home, which can be in units per month? If you have some, if you have some ideas, you can post your answers in your chat box. What is the average electricity consumption in your home monthly? Or yeah, so these are all the answers we have seen. So approximately it is between 200 to 250 units, we can say, right? This is the monthly consumption. Do you have any idea that what is the peak demand in your home? For example, that when all the most of the key electrical appliances are on at your home, what would be the peak demand in kilowatt hour? Kilowatt, sorry, not in kilowatt hour. What would be the peak demand in your home? Say 3 kilowatt, 4 kilowatt, 5 kilowatt. Let's say that we are turning on one air con, the two air cons are on at a time, or the TV is on, or the refrigerator is running all together. What should be the average peak consumption? 3 kilowatt, 2 kilowatt, right? Okay. So we have two answers now. That is that the average electricity consumption in our homes are 200 to 250 units per month, or let's say 300 units per month means we are consuming 10 kilowatt hour per day, and the maximum peak demand can go up to 3 to 5 kilowatt. In a big homes it will go up to 5 kilowatt rating. Now, what is the relevance of this question here? Like, let's go. So we will again look at the EV charging. This is what we have already seen. I just brought the same slide again. We are connecting our electric vehicles to charge by connecting them either to our home or by connecting them to the charging station. However, they are connected to the existing utility services only, right? The utility services, for example, that when you are connecting an electric vehicle to your home, the electric vehicle is acting as an additional load on the home on top of what we have been talking about now, which means that we said that the peak demand of the house can go up to 3 kilowatt, isn't it? And the consumption per month is going up to 200 units. Now, we are just looking at the same slide which I have brought on the other day. For example, that let us say that I own a Tata Nexon which is having 30 kilowatt hour battery and which can charge at the rating of 7 kilowatt, which means what is happening here. This is another statistics which I have brought from based on the data available. In India, the average household needs 5.7 kilowatt hour per day. So when you look at the number here, if you put it 6 kilowatt hour per day, someone has given the number of 180 units, right? So it is closely matching to 180 units, or we can say 200 units in some houses, 250 units. But however, The average household has 5.6. So when you look at the number here, what is the finding here? The Tata Nexon, which we have seen, has a battery of 30 kilowatt hour, and which means that when you are fully charging your car, what does it mean? The capacity of energy which consumed by the car is five equivalent to 5 to 6 households in a day, right? And a study found that the China's existing power grid can withhold only less than 20 percentage of petrol diesel engine vehicles if they are converted into electric vehicles. The electric vehicle market is improving, rapidly growing, and all that's all okay. But the problem what we are facing here is now you can imagine that if the car is connected, like that is what I said. The maximum demand in our house is 2 to 3 kilowatt, and when you are connecting a car for charging, for example, this Tata Nexon will charge at a rate of 7 kilowatt, which means the peak demand of the house automatically goes to 10 kilowatt. And if you are charging your car, let's say that you are charging your car 10 times in a month, which means that you charge your car only 3 days, I mean, once in 3 days, which means that we are charging the car 10 times in a month. What would be the energy consumption now? So every time when the car is fully charged, it is 300 kilowatt hour, sorry, 30 kilowatt hour, which means charging the car alone will be 300 kilowatt hour. As we have seen here now, the average consumption in the house is 200 to 250 kilowatt hour. But electric vehicle charging alone is more than that of most of the houses' monthly consumption. So what happens here? What we are seeing here is the vehicle mobility, actual vehicle commuting from home to work and from work to home. Vehicles, it is at its peak at 9 o'clock. I mean, it goes to peak at 8 o'clock. 30% of the vehicles are moving from home to work at 8 o'clock, and nearly 50% of the vehicles are going to work at 9 o'clock, and nearly 10% of the vehicles are going at 10 o'clock. Then this is another scenario in the evening time for home to work. However, the red color is showing work to home. Work to home usually start from here, right? This is 2, 3. But again, there are some numbers here which are not visible. However, 7, 8, 9 are reaching its peak. Let it be. So this is a scenario of electric vehicle. Now what is considered here, as I mentioned before, electric vehicles are really considered to be high power dynamic loads. Why they are considered to be dynamic loads? Because they are mobile in nature and they don't have any specific pattern. For example, that in houses there is a pattern that we turn on the lights between 6 o'clock to 7 o'clock, or we may have a habit of going to bed at 10 o'clock or 10:30. Then there is a system we follow at home, but the electric vehicle charging doesn't follow any system. It may differ. That is why they are called dynamic loads with dynamic mobility loads. And what will happen, if you have a look at this one, this is the typical power grid of a particular district in Brunei Darussalam. This is based on the data available from the utility service provider. At 6 o'clock, it started going down. At 9 o'clock, it reaches its lowest value because in Brunei Darussalam, the office hours are a bit different. The office starts at 7:45. Then 12:15, there will be a break. Then the offices are over by 4:30. As you can see here, after 3 o'clock, it is going up. It is reaching its peak at 6 o'clock. Then it's slowly going down. After 24 hours, it's going down here further. And as we know that this is mostly following a duck curve of the demand. This is the scenario of charging of vehicles. So when we look at the charging scenario of the vehicles, you can see that after 4 o'clock, the charging count events are reaching its peak, and at midnight it really go to the peak. Then during the night, because in most cases we are charging the electric vehicles at night. If you are charging is relying on your household charging, the charging will take place mostly at night time. So while we look at this data and look at this data from here, As it is trying to go down, it is going to the peak. So ultimately, electric vehicles will definitely overload the distribution grid. Do you have some idea about this question? Would you like to put some answers for this question? What are the impacts of EV charging on the utility grid? What it can cause? Harmonics? What are the other impacts? What other impacts the EV vehicles can be can create? Sorry, EV charging can create on the grid? Losses? Voltage fluctuations? Nice, yes. Harmonics and voltage fluctuations, of course. What else? Any other answers? Varying dynamic loads. So obviously, this very dynamic loads will affect the overall peak demand, right? It will definitely create an impact on the demand, and all the power quality related issues will come in. So ultimately, it will affect the stability of the grid. We can say that it will ultimately affect the stability of the grid. Thank you for those who responded. We will move on further. Here are the impact of EV electric vehicle on the power grid. So what are the key impacts it will create? It will create voltage instability. Obviously, it increases the big demand because of its dynamic nature. Power quality problems will arise. It increases the power losses. Someone has already mentioned that. Transformer heating and overloading because of the uh, sudden peak or sudden demand, quick demand or very high demand, then it creates harmonics issues and frequency instability issues will come on. All these things will they are all called as adverse impact. The only positive impact of having electric vehicle on the power grid is V2G technology. Okay, we will quickly go through all these things one after another in order to understand. Then I will just go to the actual discussions. Voltage instability and phase imbalance is what we have seen. Because how does it happen? As we know that whenever there is a sudden demand on the network, what it will, the first thing which will happen to any network is that it will create voltage instability. Obviously, when there is an voltage instability, then the EV charges will, I mean, likewise, the single phase EV charges are when connected because the EV chargers are connected. Most of the home-based EV chargers are single-phase EV chargers, and the utility grid doesn't know to which phase they are all connected, and they will lead to phase imbalance. According to a study, it is said that rural power distribution faces high voltage drops, and that need to install voltage regulation devices due to the impact of electric vehicle on the grid. Then overloading is what we have already seen. I don't want to read everything. I will just quickly go through this because overloading, why we are talking about the overloading of network. As I said before, I mean that I remember that I mentioned something during last session also. Electricity coming to our home is the last stage of the transmission, generation, transmission, and distribution system, right? So distribution is the end customer point. Before that, there is a generation system and the transmission system. But however, when you look at the generation side aspect has a huge planning and market which decide how much electricity is required hour to hour. And all of a sudden, when some amount of quick loads are coming into the network, it will severely affect the network and it will overload the network. Where it will end when we are looking at our aspect, like if you remember the diagram which I have shown, or since you are all electrical engineers, most of your electrical engineers are teaching in the teaching field also. When you look at the distribution level, we are relying on our local transformer, right? Local distribution transformer in our community that is been already designed for certain amount of load, right? When the loads are keep on increasing, or when number of vehicles are connected at a time, the demand will definitely increase. So it will overload the transformers also. A study says that the transformer cables can handle up to 25% EV penetration for slow charging and only 15% for fast charging, which means that it will create impact on the transformers also. Other things are what we have already discussed. One of the key thing here is this evening peaks, because in most cases when we go to home, like what is our habit of charging our mobile phones? When we mostly charge our mobile phones, when we are going to the bed, we have a habit of charging our mobile phones, right? And that is what we are practiced to. When we are done with everything and when we don't need the mobile phone, the last thing we do is charging our mobile phone. In the same way, once we are done with everything outside, when we go home in the evening only, we will plug our electric vehicles into the charger to charging. But ultimately, that will further increase the evening peaks. And the infrastructure upgrades are required in order to meet the demands which are coming in the future for the electric vehicle charging. Other things we have already discussed. So grid stabilization issues will occur when we are having renewable energy integration. Then again, that will create new challenges that we will see in the forthcoming slides. Okay, so here we are coming to the core point of where we are going to apply artificial intelligence technologies in EV charging. Have a look at this one. This is energy management system with a tertiary control, where tertiary control is having the market planning, buying, and selling of electricity. Everything is there. In the modern grid system, as we know, I also highlighted that during the last session that one of the efficient way to make the electric vehicle more sustainable is integration of renewable energy. Even otherwise, there is a high amount of penetration of renewable energy coming into the grid system. Charging load is a new thing which is coming into the system. We have electricity market and the renewable energy source control. These are some of the pillars of this energy management. These are some of the components which are coming in order to have a proper energy management system. So when it is coming for the energy management system, what the energy management system takes into account? Let us go back to this one again. This is a hierarchical control of electric vehicle charging system. When it is coming for the charging system, it is not just the charger. It is not about just maintaining, or it is not just about controlling, monitoring, or optimizing the EV charging. It is beyond that. The boundary is too big for electric vehicle charging, because electric vehicle charging is not only on the electric vehicle, it is on to the entire grid system. So when you look at this one, considering the power sources, there are conventional based power generation and renewable based power generation. As you might have, as most of you may know that there are significant amount of researchers have been handled or been published in order to have, in order to apply different AI and ML tools or algorithms for renewable energy generation optimization, for example, right? When it is coming for energy management system, the intelligent control system or optimal economic charging can be implemented with the help of AI or ML algorithms. We all know about the smart grid. Smart grid need an intelligent controller in order to maintain the power sharing or power balance between the different subsystems, where again This is act as a lies between the grid and charging station where we can apply the AI tools or ML algorithms for controlling the smart grid. Then there are other scenarios where managing the CO2 or reducing global warming is subcomponent of the hierarchical control of electric vehicle charging system. There are plenty of studies which are applying different types of machine learning or artificial intelligence tools to analyze the emission reduction or impact of emission due to the impact. The impact. Then, when it is coming for the system design, there are three key aspects which I have mentioned during the last session also: the converter, battery, and charger. In all of them, we are using several sophisticated artificial intelligence and machine learning based algorithms for the system design and also for the optimization. When it is coming for battery technologies, the second life battery usage has become hot topic among the electric vehicle researchers. They are now instead of studying about batteries, now they are studying about how to make use of the second life batteries which are coming out from the electric vehicles. This one will give more insight on. Let me show that. So I already added the source from where this data has been copied. So by the time when you get the slides, you can just copy and paste this in Google in order to get the full paper. That will give you more insight on this one. When you're coming into the application of EV charging further, has the same thing, tertiary control. But what is here, you know what? Well, as we know that we are talking about the renewable energy sources. Renewable energy sources are uncertain in generation. When it is coming for the electric vehicle charging is also uncertain on the grid system. So there are plenty of approaches which are used for, that the market or the research on renewable energy sources well matured, and even in recent time, the researchers are publishing several papers using different artificial intelligence technologies or machine learning algorithms. Now they are further diving into deep learning methods, or the physics informed neural networks are also being currently used for renewable energy forecasting. Such kind of similar approaches are also used for electric vehicle charging forecasting also, because load forecasting is not a new problem. In the same way, we can easily predict the electric vehicle charging once we have good amount of data of the charging behavior of vehicles on the network. So by having all these informations, see here, the energy management system has renewable energy forecasting, the information about the loading, then the real-time electricity market, renewable energy generation, demand response, and also having a tertiary control. Energy management system can individually monitor, control, and optimize the entire system so that EV charging can be definitely optimized. This figure is another scenario which shows in a more informed way how the dynamics is working between. When we are coming here again, it is more or less the same of what we have seen, but it gives more, this is more appealing picture where we can understand it quickly. When it is coming for the distribution system operator or transmission system operator, they are having all this one. The transmission system, distribution system, generation coming from renewables, and also the charging. The data gathering and scheduling will collect all the information, and according to the information, it will optimize the entire system operation, where the electric vehicle data is also going between the system. Those things are whatever we have seen here are presented in a different format here. Okay. So one of the key approach in the electric vehicle charging is charge scheduling actually, because ultimately what we are expecting to do is optimizing the objective, the main objective or main aim of the problems in most cases is to stabilize the grid or optimize the grid supply, or we can say that reduction of, there are several objectives, but the key objectives are to optimize or stabilize the grid. So here, the charging approaches are mainly classified into three. Centralized approach, where EVs will go to the central charging station, and aggregator will arrange the vehicles in such a way and schedule the vehicles to charge based on the informations provided, which is the depart arrival time of the vehicle, departure time of the vehicle, and the amount of energy required. Here, the aim of the aggregator is to satisfy the need of the user and the grid by optimally scheduling the vehicle. What is a decentralized approach? Decentralized approach is also known as a distributed method, where we decide when to charge our vehicle. We don't give the control to someone. When I go to home, I will plug my vehicle and I will set it to charge it starting from 11 o'clock, for example. That will work in that way. These are different types of charging methods. What we have seen before are the charging approaches, and these are the four charging methods. Uncontrolled charging is very straightforward. Whenever you connect the vehicle, vehicle will start charging immediately. It will not wait for anything. Vehicle will charge until it reaches full charging. Delayed charging. In delayed charging, what happens is that though your vehicle is connected at a particular time, the charging will take at its own time. Or, for example, when you are taking your vehicle to the charging station, there will be a specific parking area where you will be asked to park your car. Then the aggregator will move the car to the charging lot when it is available for charging. In the smart charging, the approach is more automated, and it is available in both public and private charging stations. What happens here? The vehicle will be charged at the same time. It will use the vehicle to grid technology in order to supply back and forth. Then the smart discharging is what I have mentioned about vehicle to grid charging. Right? The scheduling environment will take the different pricing schemes where real-time pricing is available, time of use pricing, critical peak pricing, and real-time rebate are the four pricing schemes. But when you are looking in the Indian scenario has only flat pricing. I don't know whether time of use pricing is available in India at the moment. Again, when it is coming for scheduling tools, mathematical solutions, then evolutionary algorithms like PSO, genetic algorithm, or the other optimization techniques like AI and ML applications are also, AI or ML algorithms are also used. This is just a sample of some of the algorithms which are available. What are the goals or aims of charge scheduling? To minimize power loss, to minimize the voltage fluctuation, to reduce the peak demand, to reduce the overall energy cost, and to improve or increase the renewable energy source contributions. We already seen the pricing schemes there. This slide is giving a quick overview on how the different pricing schemes are taking place. In most part of Australia, time of use pricing is being used. In some cases, actually real time pricing is available uh, for the electricity market, which is not affecting us directly, but it is affecting the electricity purchase in the large scale by the utility service providers. So what we generally know about electric vehicle charging or electric vehicle technology is vehicle to grid technology only. Most of the times we talk about vehicle to grid technology, and also charge scheduling optimization is what we know about. I just would like to give overview of some of the other techniques which are available associated with electric vehicle, which is the first one is vehicle to home. How this electric vehicle to home concept work? Instead of sending supply to the grid, the energy available in the car will be utilized to meet some loads in the house. So it is using a bidirectional EV charger is used in order to meet the load demand at the house alone. So it is working independently. For that, the islanding will be takes place in order to disconnect the house from the grid. So that whenever the grid is being disconnected, then the EV charger will come to know that it is being disconnected. Then the charger will take supply from the car to the house in order to meet the load, where hybrid inverters are used along with the solar battery system. This is one approach which is called vehicle to grid. I don't know how much you are aware of this vehicle to load. Vehicle to load technology is a very specific technology where you can directly connect any load by plugging it on the car. I will show some typical examples here. This is the three plug points which are available in Ford F-150 Lightning EV, which has two V2L AC power outlets, which are 2.4 kilowatt, and one of them is 7.2 kilowatt. So there are three power outlets available. For example, that when you are making, like when you are making chutney in the morning, using your mixer grinder, and all of the sudden if there is a power shutdown, you don't have to worry much. You just take it to your car, plug it in the car, and prepare your chutney, so that life will become easy. This is how it is working actually. It is not connected through a charger. If you look at this one, the load, AC load, is directly connected to the car, but it has the limitations. This is a limitation what I have talked about. There are two 2.4 plugs and one 7.2 plug available on this car, which can be effectively utilized. Likewise, BOED's Auto 3 V2L adapter is coming with two plug points. If you see that, it is, sorry, not plug points, it is coming with two sockets of 10 ampere. So you connect this one to the vehicle and connect your appliances here and just use them to power up your appliances. So this is the concept of vehicle to load. And the last one, or most interesting one, is vehicle to vehicle. We have been talking about this one. If you remember, on the other day when we have been talking about the electric vehicle charging, and the range anxiety is one of the key problem which we talked about. When it is coming for the range anxiety, when the vehicle is, like vehicle run out of battery, we cannot do anything. But the new vehicle to vehicle technology is allowing a vehicle to charge, like just like that of, like it is possible to charge a phone from another mobile phone. You can charge a mobile phone using another mobile phone, right? The same technology is working here. You can charge an electric vehicle by using another electric vehicle. I will just play this video so that like this is a video which I have taken during my visit to Kia Nero 5. Let me check whether this video is working here. Yeah. So this is the electric, I mean, engine part of Nero EV6, which we have visited. This is the adapter of, I have already shown it has two adapters. It has got its plug. So this can be directly plugged into the car. That's what we are seeing here. See, it can be directly plugged into the car, and we can connect a plug here. This is going into the charger, and we can just plug anything. We can connect vehicle to load actually. So the thing is that we can connect vehicle to load, or we can connect another charger. That is what this guy is doing now. So it is going through the electric vehicle supply equipment. Using this one, you can connect another car. This can be directly connected to another car. We did not connect it to another car, but I just did a demo with the help of them in order to, like this is to show that this is a real-time application actually. Okay, so I hope that you got some idea about how this vehicle to vehicle work, or vehicle to load. These are some of the examples which are having options. Nissan Leaf has both vehicle to grid and vehicle to home. Outlander also has vehicle to grid and vehicle to home. Hyundai Iconic has vehicle to load. Kia EV6 has vehicle to load. That is what I said now. But this vehicle to load can be anything, right? Load can be another vehicle even. That is what I mean. Then Genesis has vehicle to load. BOED Auto has vehicle to load. BOED Seal has vehicle to load. Ford, what I have shown you already, it has total of 9.6 kilowatt vehicle to load, and MG also has vehicle to load. If you get an opportunity to visit any MG cars, because it is available in Indian market, you can just explore more on this. Above all, the another important or most interesting technology is vehicle to everything. We call it as vehicle to X, where so if you look at this one, vehicle to network, vehicle to vehicle, vehicle to network, vehicle to pedestrian, or pedestrian to network. All these things are taking place with the help of some of the most sophisticated, intelligent technologies. What is the purpose here? So, this vehicle to pedestrian, vehicle to sensor, vehicle to internet, or vehicle to road, or even vehicle to vehicle is a new generation of information and communication technology that connects vehicles with everything. With those things, I am done with the presentation of today's session. I just gave you an overview of what is the current electricity market and how the electric vehicle can impact the grid. What are the solutions we have? How we can apply artificial intelligence technologies or machine learning tools? In what way they can be incorporated? Just to give you an overview once again, or just to summarize these things, there are several aspects where we can really apply this. Artificial intelligence techniques starting from charge scheduling. For me, actually, I have published a few papers on charge scheduling. If you go to my Google Scholar, you will find some of those papers available there. Other than that, we are applying these technologies for optimization of the grid power, optimization of the battery energy storage system in the charging station, energy forecasting of the solar PV system. Based on energy forecasting of the solar PV system, we can schedule the electric vehicles in order to minimize the overall charging cost. At the same time, that can be used to minimize the issues associated with the grid also. Right. So, whatever I have said are given as points here. Okay. Thank you very much. I have done with the presentation, and if you have any questions, you can ask me now. Yeah, I think that we have 5 minutes time.
Uh, Thank you, Professor Dr. Sheikh Mohammed Sultan. It's a wonderful presentation. Participants, if you have any questions, please unmute yourself and you can ask your question directly to the resource person. Next 5 minutes has been allotted for question answer session with the resource person.
Okay, it seems there are no any specific questions, and thank you very much. I would like to thank once again the organizers of the FDP for giving me an opportunity to share some of my knowledge, understanding, and expertise in the field of electric vehicle and charging technologies. I hope that it will definitely give some takeaways to the participants who are attending this FDP, and I wish the organizers a great success of this FDP. Thank you very much.
Thank you, sir. Thank you. Thank you.
Okay, I will take a leave from the meeting now. Okay, thank you very much.
Dear participants, you can take another 5 minutes break. I have invited the speaker of the next session. I have given 7:15 for the next speaker. So I have given a call also. I have sent a message. Hopefully, he will join within 5 minutes. Therefore, I request all the participants to take 5 minutes break and come back for the next session.
ஒளிவா டெய்லி பழக்கம் ஒளிவா ஐயா திரு விவேகானந்தன்
Sir, we'll start the next session shortly. So meantime, we'll take virtual group photo. Can you switch on the camera? I request all the participants to switch on the camera so that we can capture the virtual moment.
Good evening, sir.
Good evening. Sir, good evening, sir. Welcome.
Good evening. Good evening. Am I audible?
Yes, sir. Yes, sir.
Good evening, sir.
Good evening, ma'am.
Good evening, sir.
Yeah, thank you all. We can move on to the next session.
Your voice is not audible, sir.
Sir, ready, sir? I have given you co-host privilege. You can share the slide. And we'll move on to the next session. It is my privilege and honor to introduce the session speaker, Dr. S. Ramareddy. Sir is a distinguished academician and researcher with an illustrious career spanning more than 28 years in teaching and research. He began his professional journey as a design engineer at Tata Consulting Engineers before moving into academic as a professor in the Power System Division at Anna University. He secured All India first rank in AMIE in 1984, completed his ME in Power System at the College of Engineering, Guindy, Anna University in 1988, and went on to obtain his PhD from the same institution in 1995. Dr. Reddy has guided 25 PhD scholars. I am privileged to be one among them, and I remain deeply grateful to him for his invaluable guidance and support throughout my career. His mentorship has shaped who I am today, and I owe my sincere thanks to him. He has published over 57 research papers in reputed international journals and authored standard textbooks on power electronics, electronic circuits, and electromagnetic field. He has also secured a research grant of rupees 13 lakhs from AICTE. His exemplary contribution to academia and research have earned him several prestigious honors, including AIMO Best Project Award, the JCE Best Performer Award, the Outstanding National Academic Award from ISTE, the IET Diamond Salute Award, and the Best Researcher Award. Dr. Reddy is an active member of professional bodies such as IEEE, IE, ISTE, SPE, SSI, and IETE, and serves as a reviewer for IE and elsewhere journals. He is also a member of Board of Studies at Anna University. His academic excellence, professional dedication, and inspiring mentorship continue to influence generations of students and researchers in the field of electrical and electronics engineering. We are delighted to have such a distinguished resource person with us today. Sir will be delivering a session on the application of IoT in electrical vehicles. I am confident that this session will be highly informative and enriching. With that, I now have the privilege of handing over the session to Professor Dr. S.R. Reddy. Thank you, sir. Over to you.
Yeah, thanks for the kind introduction. Am I audible to the?
Yes, sir.
Am I audible?
Yes, sir. Perfectly, sir.
My PPT is visible?
Yes, sir. You can go for slideshow, sir.
Very good evening to the audience. I would like to give some information regarding IoT applied to electric vehicles, because this program is pertaining to electric vehicles. I thought I will spend some time on renewable energy, because your title says renewable energy and electric vehicles. So I will be focusing on these two. So IoT is a network of physical devices, appliances, and sensors. So it can convert things like human beings. There are several areas for IoT. Some of the areas are mentioned here. So I'll be talking more about smart grid and transportation, that is electric vehicle. Your efficiency will improve and decision making will improve, and new opportunities are there with IoT applied to our electrical systems. So to start with, we will see in smart grid. So microgrid is a reduced version of large grid, or what we call it as finite bus. Infinite bus, if it is large grid, microgrid is a finite bus. So large, you have constant voltage, constant frequency, infinite inertia. So when it comes to smart grid, you are integrating communication with your microgrid. So the happy marriage between microgrid and communication has produced a beautiful child. So the name of that child is smart grid. You can see communication plays a vital role in smart grid. This is microgrid, where you have different renewable sources. Trend is to go for home-based microgrid, connect all the devices to your renewable sources at home. So the issue is blackout. In USA, there was total failure or total black. They called it as blackout. Whenever low voltage is there, the lamps, your incandescent lamps will be in brown color, that is brown out. Then large generator stripping instability, and you disconnect the load, that is load shedding. So these problems can be solved in smart grid. You have a lot of sensors, you spend a lot of money for the sensors. Wherever possible, you fix sensors, smart processors, smart meters, and IoT, and automatic adjustment using closed loop. So in smart grid, we'll have more closed loops compared to conventional grid. So major components, wireless communication and artificial intelligence. Little bit about artificial intelligence, maybe one or two controllers I will touch today. So one advantage with smart grid, what is the difference between smart grid and conventional grid? So if it is normally operated grid, when there is a fault, all the lines will be tripped. But with smart grid, because of the large number of sensors, that area where this problem is there, only that part will be isolated. You can see the left hand side and right hand side. Very few points will be isolated if it is smart grid. So advanced metering, grid control, predictive maintenance, and energy storage management, these are all the applications. You can apply any modern algorithm. Some of the speakers would have spoken to you about machine learning algorithms, etc. Any new algorithm can be easily implemented. So this is your comparison between normal grid and existing grid. So now people are going for this renewable sources at home. Then we go for net metering. Net metering means you will be paid for the net units. You are consuming some units, you are supplying some units. So the net unit consumed is number of units actually consumed minus the number of units supplied. So advantage of net metering, you are paying for that in-house generation or in-plant generation, whatever generation you have, that units will be subtracted. So for this, you have the smart meters. So smart meters can give you a lot of information. Mainly, what is the cost of energy? You know, different vendors are there. Each vendor is quoting one amount. So you can select who is the low cost vendor and buy the power from that low cost vendor. When it comes to the meter developed by Google, Google has developed a meter. So it is giving real-time energy consumption. Then you can decide what to do and all. So in non-conventional, a lot of data will be there. You have PV data throughout the day, how the illumination is changing, how the output voltage is changing. Similarly, if it is wind source, wind parameters will be there. That is wind velocity, then your output voltage, etc., etc. So in IoT, you have the provision to store the data in the cloud. All that data can be stored and that can be used for future purpose. So it's green power and it supports the main grid, reduced carbon emission and better energy management. But when you add more power electronic converters, harmonics are there, and your power is unreliable and the lithium batteries are costly. That is the problem that we are facing. Now people are recommending sodium batteries. Lithium batteries have thermal runaway problem, means due to excess temperature, the lithium battery gets damaged. But sodium battery does not have this thermal runaway problem, but the cost of sodium battery is 5 times the cost of lithium battery. So some of the states have done well as far as DC microgrid is concerned. We are going back to original DC, what we had few decades back. So here loads are DC loads, and you have a common DC bus. I think you can standardize your laptop to 12 volts, mobile to 12 volts, lamps to 12 volts, LVDC fan, etc. If everything you standardize to 12 volts, you can have a 12 volts DC bus. From that, you can connect to the DC loads. I think Kerala has gone for a lot of DC microgrids. So in future, you will have more and more DC microgrids. So coming to electric vehicle, the interesting combination of motor and power electronics has produced another beautiful child. Again, that name of that beautiful son is electric vehicle, which needs strong background of EV. EV needs strong background of power electronics and machines. So IoT application in EV, remote monitoring, smart charging, driver behavior analysis, control of power from vehicle to grid. How much power you are pumping, that can be controlled because you have the power electronic controller. If it is DC controller like boost converter or buck converter, you control the pulse width. Basically, delta is in your hands. If you are doing with inverter angle should be higher than the bus angle, then real power can be transferred. So by controlling the phase shift of the pulses in the inverter, the power, real power can be controlled. And by controlling the pulse width, the reactive power can be controlled. So reactive power flows from high potential to low potential. Real power flows from a bus with high angle to a bus with low angle. So higher efficiency, improved range, enhanced safety, vehicle to other devices communication. So you will get an idea if you see this, how IoT based EV charging will be very helpful. So you are giving the communication that you want to charge your vehicle. That communication reaches the cloud. The cloud will give a reply to your mobile, and in your mobile app, the nearest charging point will be informed. Then you can go to that slot. So due to integration of your communication with the electric vehicle, it is easy to identify the charging point what you want to use. So that's what this diagram is showing you, how your IoT helps you to give the location of the charging station. So sensors are there. You have sensors to inform tire pressure, to inform the battery condition, then brake system, then electric motor, temperature, etc. So there are so many sensors embedded in your EV, and these sensors give the data and decision can be taken accordingly. So smart charging, you have smartwatch, you have smartphone, like that smart car. Future all cars will be made smarter. Then this smart EV charging system will also give you the information about the tariff, etc. So you are again, it is making communication between the charger and the vehicle. So this figure gives you an idea about the EV charging, smart EV charging. So if it is battery, the battery tester is one equipment which is very costly. Battery tester will be few lakhs depending on the accuracy what you want. So with the help of battery tester, you can measure SOC of the battery, etc. So you have different parameters: SOH, SOC, state of health, state of charge. All this information goes to your processor, your Raspberry Pi. From there, it is communicated to the cloud. So this is the battery system in electric vehicle. So Tesla has implemented the updates, OTA updates and telematics. Nissan has gone for battery monitoring and smart charging. Ola is using app-based ride control. Startups like ATAL and Revolt, they are using IoT for personalization. These are some of the implementations. And your electric car is provided with a lot of electronic control units, ECUs. So these ECUs will give you the mobile. Mobile has one control unit. For charging, you have one control unit. Then communication with the nearby vehicles, you have a electronic control unit. So with the help of electronic control units, the efficiency and safety of your electric vehicle is improved. That's what you find in this figure. So BMS involves estimation, state of charge, state of health, thermal management, all these things. So it will detect whether any overcharged cell is there or disconnected cell, temperature, state of charge, etc. Like our SOC is 100% when we come to the office in the morning. As we go towards the evening, our state of charge will decrease. State of health in the beginning of our career will be very good. As the age progresses, our state of health will decrease. So the same thing is true with the battery. The battery has something called first life and second life. First life is with the electric vehicle. And once EV people throw out the battery, then it has a second life where we can use this lithium-ion battery for UPS. So what is this thermal runaway problem? When temperature increases, more covalent bonds are broken, more electrons will come. Then more heat, again more heat, more covalent bonds are broken since you have the semiconducting material. And this process continues. If you don't apply a brake to this cumulative rise in temperature, the battery will get damaged. This is what we are hearing. The fire accidents in lithium-ion battery are due to thermal runaway problem. So we spend a lot of money for protection because we want to protect the battery at any cost. If you buy a electric vehicle for 20 lakhs, out of that 12 lakhs will be the cost of your battery. Therefore, you have to protect your battery. So the protection of battery is similar to protection of your alternator. For your alternator, any new protection strategy is suggested, immediately people will implement. Similarly, in BMS, any new protection method is there, we will implement. So fuse gives the overcurrent protection. Current sensing we do with a low resistance using the shunt. Generally, whatever sensor outputs you are getting, we have discussed about so many sensors. The sensor output voltage will be very less, but your processor, your whatever processor you are using, TMS or STM processor, whatever processor you are using, they want a good amount of signal. So we generally keep the sensor as one of the arms of the Wheatstone bridge. To that Wheatstone bridge, we give higher DC voltage, maybe 5 volts or 10 volts like that. Then a small change will produce large change in the output of the Wheatstone bridge. So your Wheatstone bridge comes along with the sensor. So if you see what is there inside the sensor IC, inside the sensor IC sensing element plus one Wheatstone bridge will be there to get that required signal. So you can see a thermistor. Thermistor is basically a negative temperature coefficient device. Whenever temperature increases, the resistance decreases. So thermistor happens to be one of the arms of the Wheatstone bridge. So when temperature increases, the resistance of the thermistor decreases, and the corresponding signal will be coming from the Wheatstone bridge. So the output of the Wheatstone bridge is proportional to change in the temperature. So all these things through ADC, you give it to your processor, and your processor will take the decision. So you have passive balancing, active balancing. Passive balancing, we use some resistor to dissipate the excess energy, but active balancing, from a cell with higher voltage to a cell with lower voltage, we use a DC to DC converter. This is a flyback type of DC to DC converter, where I have a cell with higher voltage, I have another cell with lower voltage. Then I will activate this DC to DC converter, transfer the energy from the cell with the higher energy to the cell with lower energy, which we call it as active cell balancing. This is where you find your DC to DC converter applicable in this. So if somebody is doing research in this area, if they are good in power electronics, they can change this flyback converter to some push-pull converter or isolated type DC to DC converter, and do some changes in the circuit, then get some results, make a comparison. You know, comparison is one way of getting a paper. So you are nowadays, you are also using digital twin. I think way back when Shankar has directed a movie, Jeans. In Jeans movie, there is a real Aishwarya Rai and there is a digital twin he has created several years back. So this director of Bahubali, Rajmouli, he has created Mahishmati, which is a digital twin of Hastinapur. Using computer graphics, he has created. Similarly, he has created a character Bahubali, which is an analog twin of Arjun. So what is this digital twin? Digital twin, it will be difficult to handle big system. Say for wind generator, we have a digital twin. For a 10 megawatt solar system, we have a digital twin. For every renewable source, we have a digital twin. So if you see in that movie, I told you Jeans movie. In Jeans movie, if the original Aishwarya Rai is turning her head left side, digital twin also will turn the head in that direction. If it makes one full turn, digital twin also makes one full turn. So like that, if there is a fault in the real wind generator, that fault is seen in the digital twin. Similarly, in PV system, if there is a problem, that problem will appear in the digital twin. So that is why nowadays every industry is trying to do a digital twin for their industry, so that the control becomes easy. Probably the best project work would be to develop a digital twin for your college. So BMS displays the message as overcharged, overheated, cell damaged. These are all the different types of messages you find in BMS. There is something called end of life. So if end of life is less than 80%, it cannot be used in EV. We said there is a second life for this. It may be used for UPS. So factors affecting the degradation, charging current, discharging current, and depth of discharge. So they are giving a safe operating area for that lithium ion battery. You have to operate within that safe operating region. You should not go to the dangerous area. Temperature you should not exceed above Tmax. Similarly, below T minimum, you should not, whatever temperature they are giving, within that you have to operate. Similarly, for current, within that temperature. So If you operate within that safe zone, nothing happens to your battery. So in BMS, you have distributed architecture and central architecture. And electric vehicles are going for wireless charging. So this wireless charging, you will easily understand if you know isolated type of DC to DC converter. So in their in power electronics language, it is converter 1 and converter 2. In communication language, they are saying transmitter and receiver. So this is your high frequency inverter, which produces this high frequency field, which links with the secondary of the transformer. Secondary output is rectified using your rectifier. So your rectifier part or receiver part is in the electric vehicle. This is in the charging station. So when you are bringing the electric vehicle to the charging station, then energy is transferred magnetically. The principle of energy transfer is magnetic transfer. I think some of the countries have got e-highway. So throughout the e-highway, they have gone for this. And during running itself, it gets charged. So in our institution, we have developed one project. In that project, it is solar-based scooter. In the solar-based scooter, there are 2 batteries. One battery is controlling your motor, giving power to the motor of the electric scooter. Parallelly, another battery during the running condition that is getting charged. So whenever previous battery is getting discharged, the other battery can be connected. So using 2 batteries, how to charge the electric vehicle during running condition, that idea is used, but you need 2 batteries. That will increase the cost. So people are going for fast charging. Fast charging is 400 volts DC. You have level 1, 110 volts, level 2, 230 volts, and the level 3 is 400 volts DC. So Tesla has gone for 400 volts DC, where they claim the charging is very fast. So this is with microgrid. So AC microgrid based, if your bus is AC bus and you are connecting your EV etc. to this side you have solar, wind, etc., diesel generator, fuel cell, all these things. So wherever DC source is there, you need a inverter. So from fuel cell output is DC, so DC to AC. You have the AC bus. From this you can connect to the grid. You can give it to EV, etc. So this is the AC microgrid based infrastructure. So since your program is on controllers, I thought I'll discuss at least one controller. So what is linearity? Linearity is getting what you are expecting in proportion. Morning first 2 hours of class is linear. Whatever you teach, they write. And last 2 hours of class is non-linear. You write something, they copy something else. So if you take a pure resistive load, if you apply sinusoidal voltage, it draws sinusoidal current. That's a linear load. But nowadays you have more non-linear loads. Non-linearity means it is not following that relation y equal to mx. Maybe y equal to mx plus c or any non-linear equation if you have, that is non-linear load. So your cell phone charger is a non-linear load. EV is a non-linear load. Solid-state DC drive is a non-linear load. Transformer, even though you give sinusoidal voltage, it draws slightly distorted current. Induction motor, you give sinusoidal voltage, it draws distorted current. So they introduce distortion or harmonics. So fuzzy logic, these are the membership function, these are the variables. So you do fuzzification, then implication, then defuzzification. So I'm just giving one simple figure for you to understand. Fuzzification is like ADC. Implication is done in your processor. Defuzzification is like DAC. If you take any application, microprocessor based application, or simple your calculator. If you take your calculator, in calculator you give analog numbers, but the processor is a digital processor, it will get the answer in digital. But to a common man, if you give digital answer, he cannot understand. Then digital has to be converted into analog. So the architecture of your calculator or architecture of your microcontroller will have ADC, then processor, then DAC. So your fuzzification is like ADC and your defuzzification is like DAC. So the inputs are error and change in error for your fuzzy logic controller. If it is chopper or any converter, it is false width. If it is rectifier, it is firing angle. Maybe some more, I can give some more examples. With the example, if I explain, then it will be easy. So, TVS wanted to develop a washing machine. So they want to go for a fuzzy logic based washing machine. So they took inputs from servant maids. They called the servant maid. One servant maid said, I will add surf based on number of clothes. Another servant maid said, I will take a look at the dirt. Based on the dirt, I will add the surf. Another person said, I will reduce the surf if there are more number of silk sarees. Another person said, I will add more surf if there are more number of jean pants. So they have taken all these inputs and developed a fuzzy logic. Another simple example for tip in a restaurant, let us say food is good, tip is 30 rupees. If food and ambience are good, tip is 50 rupees. If food courtesy and ambience are good, the tip is 90 rupees. Generally, whatever balance you get, that balance you give it as a tip. 50 is not 2 into 30. 90 is not 2 into 50. So some random amount you are giving depending on these conditions. So this you call fuzzy logic. I think there is a fuzzy logic controlled machine for in farms, in poultries. So in poultries, you want to feed the food to the hen. You get a lot of information. What is the age of the hen? How many eggs it has already laid? What is the remaining life of the hen? So if it is a young hen, they want to give good protein food so that it will give more eggs. If it is an aged hen, they want to give low cost food. So the selection of the food is done with a fuzzy logic. So with these examples, you will understand how fuzzy logic is used in induction machine, control of induction motor, DC motor, temperature controller. Mainly your anti-lock brake system, ABS is using fuzzy logic. So wherever I don't have that linear equation, where I have tables, no, generally we implement the projects with truth tables. What do you call it? Lookup tables. We implement the project with lookup tables. So lookup table will have some random data. So that data we give some name, medium, small, medium, big, like that, and call it as fuzzy logic. So where the system is not properly defined, we go for fuzzy logic. So your program is dealing with fuzzy logic. So I thought I'll talk about at least one controller. There are many controllers. People are working starting with proportional integral controller. Then they go for, people are working on fractional order PID controllers, proportional resonant controllers, hysteresis control. Simple example for hysteresis control is your heater. Whenever temperature goes above a particular value, heater will be off. When temperature goes below a particular value, heater will be on. So your electric heater at home is using the hysteresis control. And if you want to publish papers, you have to learn sliding mode controller, you have to learn model predictive controller. I think electric vehicles use model predictive controller because a lot of sensors are there. It predicts, especially autonomous vehicles are using model predictive controllers. So based on the sensor data, the autonomous vehicle will take a decision whether to turn left or turn right or go straight, etc. So a good knowledge of control system will be useful for your research. So one MATLAB diagram I have given what my scholar has done. So my scholar has taken a wind generator. Output of the wind generator is given to a rectifier to convert AC into DC. This output is boosted using a boost converter. So she is basically using voltage loop. It is called voltage mode control, VMC. So VMC, if you want CMC, you need both the information, both voltage and current. So actual voltage is sensed, it is compared with the reference voltage. So if actual voltage and reference voltage are compared, I get the voltage error. This error directly I am giving to fuzzy. Derivative of this error also I am giving to fuzzy. Then output of the fuzzy is compared with the ramp voltage. So the comparison of ramp and the output of the fuzzy logic controller will give you pulses. Those pulses will update the pulse width of the boost converter such that your actual voltage is equal to reference voltage. Generally in fuzzy, we select odd number of functions, 3, 5, 7, etc. We don't select even numbers. One simple example to understand in fuzzy why we select odd number of membership functions. Suppose principal wants to take a decision, he will put a 3-member committee or 5-member committee. If 5-member committee is there, out of the 5, whatever majority, 3 people take decision, that can be implemented. Suppose if the principal appoints a 4-member committee, if 2 members say yes, 2 members say no, then you cannot take a decision. Similarly, in fuzzy logic control, we go for odd number of membership functions so that taking the decision will be easy. So my scholar has basically worked on disturbance rejection study. Disturbance rejection study means a disturbance is given to the wind speed. When wind speed increases, output voltage increases, but your closed loop system will make some correction and bring the voltage to constant. If I assume wind speed is increased, output voltage increases, but your closed loop system will make the correction in the pulse width such that output voltage comes down. So this type of study, we call it as disturbance rejection study. So if you want to publish paper, you have to give a lot of tables, a lot of case studies you have to do. Step rise in speed, step fall in speed, multiple step rises, multiple step falls. Like that, you have to get time domain parameters for different cases, then make some comparison and describe the results and give your conclusion, what you are observing. So a good knowledge in control system will help you to publish papers. These are the applications of fuzzy logic controller. So coming to IoT, the projection is very great. The number of people who are using is very high. These are the advantages. So if time is there, I will go for other applications. You know, even for the how they are fixing sensors and detecting their health, their behavior, their location, and early disease detection, automatic milk collection. So if you understand smart cow, then smart grid is easy. How you are able to monitor the parameters of the cow and take decisions like that in smart grid with the help of large number of sensors, large data, decision can be taken. Smart parking is possible with IoT. One of the applications of IoT is smart parking. So you can optimally use. You need not, you just give the instruction. You can go to the shopping mall. The processor in the car will take the decision. It will go to the empty slot. You know, you are how IoT generates money. He said IoT generates money. New opportunities are there. IoT is generating more money in renewable energy sector. IoT is generating more money in EV. With this example, I want to explain how IoT generates money. Through the mobile, you are giving a request, you want to place the car. So you have to pay some money because you are using the technology and the infrastructure. So from your mobile, you are giving a request to the cloud, and the cloud knows what are all the vacant slots, and the information about the vacant slot is given to you, and your vehicle will take that path and it will go and occupy the slot. Because you are paying for this smart parking, IoT is generating money. So the space can be utilized optimally. The space can be utilized. So remote smart park assist RSPA. Some of the modern vehicles are using these extra options. You know, whenever you want to buy a car, you see what are all the options available. So RSPA is the new future, remote smart park assist. Then smart park meter accepts digital payment and shows the slot. This is how IoT is generating money, one way of generating the money. And for waste management in smart cities, so they are getting, cloud is getting information, what are all the different types of waste available and where it can be used. So to that corresponding place, it will be sent. So one of the applications of IoT is in smart cities for efficient waste management. And your smartwatch tells you how well you sleep. So you can change your habits. You can change your behavior based on this information available from your smartphone or from the smartwatch. So you can know more about yourself, so where you are going and how much time how many steps you have taken per day. All that information is available in your mobile phone. So if you have walked for less number of kilometers on a particular day, you can compensate that with the evening walk. That is the benefit of IoT. I think IoT is used even in your house for your robo-based cleaning. So all the modern robo-based floor cleaners, they are linked with your mobile. So in your mobile, there is a map showing your house floors, different rooms. If you want to clean a particular room, you can select that zone and turn on your robo. So if you turn on your robo, the robo sweeper will go and clean only that particular room. So that is the development in the technology, how IoT can be used for your house cleaning application. So integration of AI and machine learning in EV analytics, use of digital twins for EV simulation, blockchain, then future autonomous vehicles with full IoT integration. These are some of the research trends in electric vehicles. Challenges, very high cost of implementation and R&D cost is very high. Data overload and management, connectivity issues in rural areas where the internet facility is not good. There you have the issues and standardization challenges. So IoT enhances efficiency of EV or smart grid safety and sustainability. Collaborations across the industries are key need for secure, scalable, and interoperable platforms. The future is smart. The future is definitely smart if EV and smart grids are enhanced. So these are different applications of the IoT where it is used. We didn't discuss about flights. We didn't discuss about helicopters, railways, all these things we didn't discuss. But there are so many applications of IoT. So the potential, is so high. So it's more than 150 billions. That is the potential of IoT. So when 50 billion machines are connected, then you can imagine what happens. So sky is not the limit. It is the beginning with the IoT. So as more devices are improved, the country level will go up in future. So I have one technical channel in my name. Maybe I have gone through very fast. EV videos are available in my channel. Electric vehicle, Tesla Model Y, Tesla Model 3, etc. That is, originally Tesla has started with induction motor for their electric vehicle. Then they went for permanent magnet synchronous motor. Then they have combined both permanent magnet synchronous motor and reluctance motor. Now government of India there are a lot of projects in DRDO. Actually DRDO is asking for magnetless motor, magnet-free motor, that is switched reluctance motor. So if some of you can write proposals where you develop a drive without magnet, that proposal will be immediately accepted by DRDO. You will get the funding. So we are depending for magnets, we are depending on China. So the government of India wants to have electric vehicles with motors not using magnets. I think one solution is switched reluctance motor. Another solution is your reluctance motor. So reluctance motor or SRM, any of these things one can try. The other channel what I have is RR Moral Stories. So this is my mobile number and this is the mail ID. If you have any questions now, we will have the questions. Or if you want me to elaborate any particular slide in detail, I'll elaborate that slide.
Participants, now time for a question answer session. If you have any questions to the resource person, please unmute yourself and raise your question.
Sir, I have a question to ask.
Yes, sir.
Yeah, please.
Sir, you would have seen that in any Mercedes factory, there are trays that go and go to the particular car and they lift the car like a jack and they bring it to the the section area for the testings and finish line once the the PDI is over.
Yes, yes.
So you said about self parking, smart parking. The technology is coming up very soon.
Yes.
So will these things be implemented for every car that is going to come over there as a like the same concept for the self parking also?
No, only high-end cars will have this because the cost is going up with more and more options. So for all the cars, definitely it is not possible. Like Mahindra has come out with
Also, no, because smart parking,
uh,
there are a lot of sensors that don't
only for the
really.
recent cars they have come out with this feature. So ADAS level 1, level 2 is there in India right now. Above level 2 in India, it will take time for that to come.
Okay, okay, sir. Okay. This is what I wanted to ask because these days hotels also have got this feature that the car will be near your bedroom. So
Yes, yes, yes.
because that
Some
kind
hotels.
of trends are going to shut down very soon.
Yes.
So will this be effective of smart parking is the question, sir.
No, it varies from place to place. For smart parking, again, you should have the provision to install all those sensors, then to integrate your technology. If it is possible to integrate your IoT technology, then smart parking will be possible.
Okay, okay, sir. So, anyways, thank you so much, sir. Thank you so much. I was just little having a query with this kind of technology because India, there's a lot of mismanagement concept. So, how much will this be implemented, and how much will this be a success? Was my concern.
Okay, okay, okay. It takes time. It takes because we have put it in drawbacks. No, the policy again, all the policies are not yet finalized. So the government has to finalize the policies. Any other participants have any other questions?
Good evening, sir. This is Milton from Stella Maris College, sir.
Yes, sir. Yes, sir.
Sir, you had said about the two-wheeler. You are connecting the PV panel at the input side now, sir. Kindly brief about it, sir.
No, four on the wheel, front side wheel, no, two vertical rods from the back side wheel, two vertical rods, four rods to be fixed to the two-wheeler. On top, PV panel will come, which will give you the shelter. It is like the shelter, open shelter. Open shelter.
Okay.
Then the output of the
Okay,
PV
sir.
will
Okay.
be output of the PV will be charging the battery 1. Battery 2 is another battery which is controlling the motor. There is a swapping mechanism. Whenever battery 2 is discharged, then this swapping circuit will change to battery 1. So during running condition of the scooter, PV will be charging the battery. Nowadays, high density panels have come, high quality, high density, lightweight. Because for this PV based scooter project, weight of the panel decides. If the weight is very heavy, then your mileage will go down. So you should go for thin PV panel at sufficient height. Aerodynamics must be taken care. You should not have any closure on any of the four sides. You should just take four rods on top. You fix the PV panel and get that energy from the PV panel and feed it to the battery. At least there is no fear that my vehicle will stop today somewhere in between. That fear won't be there. Whenever your
Okay.
main battery is down, you have the option to connect to the second battery. So the vehicle can run, you can reach the destination.
Okay, sir. How it was swapped, sir? How it was swapped
Pardon?
through the program? How the battery was swapped, sir?
No. Our students have gone for a manual switch. So when the changeover switch is changed to other side, the second battery will be connected. Again,
Okay.
if you use technology,
Okay, sir.
sense the
Okay.
voltage, and when the voltage or sense the SOC, when SOC goes below a particular value, then the relay should make the connection to the other battery.
Okay. Okay, sir. Okay. Okay, sir. Thank you.
Any other questions you have?
Audience, do you have any other question? So I have posted today's attendance and feedback link in the chat box. All are requested to submit your feedback at attendance for the today's session. With that, we'll conclude the today's session. We extend our sincere gratitude to our speaker, Dr. S.R. Reddy, for his insightful and engaging session on IoT application to electric vehicles. Sir, your valuable expertise and thought-provoking ideas provided our participants with a deeper understanding of the role of IoT in advancing EV technology. We deeply appreciate the time and effort you dedicated to enriching our faculty development program, and we look forward to future opportunities to collaborate with you, sir. Thank you so much, sir.
Thank you very much. Thank you. Thanks for the opportunity given to me.
Thank you, sir.
Can I sign off?
Yes, sir. Yes, sir.
Thank you, Nagarajan.
Thank you, sir. Welcome, sir.